we start the integration. So this is two examples of integration by parts. Let me write the standard formula that probably most of you know about. The integration by parts formula is that if I have integral of u times dv, here u is a function of x, you can write it as u times v minus the other way around, meaning that you can write integral of v du. So this is very standard in every calculus book. You actually have this formula. But it is important to know, and usually it is used when your integrand is a product of two functions, usually. Okay, but it is important to have, because you know here you have to choose one of these ingredients, u, and the rest of it, dv, and it really matters from practical point of view. Of course, this formula will always generate correct answer. I mean, this equality is always true, but it is not always useful, because integration by parts formula reduces one integral to another integral with the hope that the new integral is simpler to calculate than our original integral. So if you do not choose u and dv wisely, still this equality will hold, but it might be the case that the integral that you generate in this way is even harder than your original integral. So even though equality remains true, but of course it will be useless, because I am not making life simpler, I am making it harder. Okay, so that is important. So the first thing I want to do as a rule of thumb, so you might say that, okay, I can take this dv, I can take this u, or I can have another combination. So I would say that this is not a wise choice. If I want to take this v, because on the right hand side you see that I have v involved, it means that from here I should be able to calculate v. In order to calculate v from dv, I have to integrate dv, which is supposed to be ln x dx. It is of course doable, but it is not the simplest possible integral to do. So as a rule of thumb, it seems that this is at least not my first choice. So what I will do, I will try to rewrite it in this way. So I will write, if you don't mind, let me call my integral I and change my color. So I is equal to, I will rewrite it, at least in my head, in this way, ln of x, and then multiplied by x cubed dx. Okay, but now look, if I take this one u, what I need to do later, I need to find du. So it means that I differentiate, which is simple. And if I take this one dv, in order to find v, I need to integrate x cubed, which is a very simple task, at least simpler than the previous case. So this already shows that this choice is a better choice. Okay, so let us go forward. So we choose u to be ln of x. We choose dv to be x cubed dx. But because on the right hand side I need du, so I calculate du. For calculating du, I need to differentiate this function, which is 1 over x, and then multiply it by dx. And in order to find v, I have to integrate x3 dx, which becomes x4 over 4, and then plus any constant, but I need only one of them, so I can choose c to be 0. Okay, so now everything I need I have. I know my u, I know my v, I know my du, and I know my dv, so everything is ready. So I plug them in here. My original integral is u dv, so I should write it as uv minus integral the other way around. So this means that my integral I is equal to u times v. This is my u, and this is my v, so I multiply them. So this becomes x to power 4 divided by 4 ln of x minus integral of v times du. This is v, this is times du, so I multiply them. So v is x to the power of 4 over 4 and multiplied by 1 over x dx. So I go forward a little bit. There is nothing much I can do about the first term. More or less I copy and paste here. and then minus this 4, which is 1 over 4 is a constant, I pull it out, so it becomes minus 1 over 4, and then I have integral. This x here and that x4 there simplify one another, so it becomes x3 dx. But then you see that I would consider this a successful u and dv because my original integral was this. I was able to reduce my integral to a new integral, but this integral is very elementary. So I would say that this choice of u and dv was indeed correct. And then of course you just continue one more step. So I copy and paste the first term, and then minus 1 over 4, but the integral of x cubed is x to power 4 over 4, and now that the integration is finished, I put an overall constancy at the end, and of course I prefer to simplify it one more step, minus 1 over 16 x to power 4 plus a constant. So that will be the answer to this problem. Yes. So let me show you the problem. I wait for you a little bit. So again, I would consider this I. I want to calculate I. Let me put something here. Sorry. Yes. So, and I want to write a formula here again. So u dv, if I want to integrate, it becomes uv minus integral v du, the other way around. So remembering it in this form is not complicated. Okay, but again, as I told you before, and now you have one more, you have one experience in your toolbox. So I hope that you see which one to take u and which one to take dv is probably useful here. If you immediately want to keep the same order and say that, okay, I want to take this u and take this v, of course, it is not technically wrong, but it is not always helpful, because on the right-hand side, you have v here and there. So from here, if you take it in this order, you should be able to find v. To find v from dv, you have to integrate ln of x to power 3 dx, which is probably not elementary at all. So if I have an option, I wouldn't take this as my first choice. I will do it the other way around. So what I can do, for example, first I try to rewrite it in a different order, meaning that, so let me change my color. So this becomes integral. I would write ln of x to power 3 first, and then I would write it as multiplied by x dx. Okay? Of course, if I do it in that way, then I will take this u and then I have to take this dv, but that is apparently a good choice because finding v from this relation is very elementary. Okay? So this means that I have a u to be ln of x to power 3, and then what I do, I immediately calculate du. But in order to differentiate the function, this is a function of x to power 3, so according to the chain rule, it becomes 3 goes down, and then there will be 1 unit deducted from this exponent, so it becomes ln of x to power 2, but by the chain rule, I also have to multiply by the derivative of the base, which is ln of x, and then I have to multiply it by dx. And now, hopefully you know that the derivative of ln of x is nothing except 1 over x. So if I write this in a compact way, finally my du becomes 3 ln of x to power 2, everything divided by x, and then I have a dx in front. Yes, well, it's always good to double check everything. So this 3 and this 1 over x, so everything seems fine. So that's my du. And the simple part here is dv. So if my dv is x dx, one of those v's that I am looking for is actually integral x dx, but then of course it becomes x squared over 2 plus a constant. But because one of them is enough for me, I just don't do any constant here. Okay? So then we put everything back in the formula. So the integral that I want to calculate is integral u dv, which is my left side. So I would put them here. So I becomes equal to u times v. This is my u, and this is what I got for v. So I multiply them. So it becomes 1 over 2x squared multiplied by ln of x cubed. Yes, and then I have minus integral the other way around, v times du. So I'm putting this in this formula. So what is v? This is your v. And what is du? Du is this one. So let me write them. So v is x squared over 2, and I multiplied by du. Du is 3 ln of x squared divided by x dx. Okay? But I can simplify this a little bit, so I copy and paste the first term. Yes, and then what I can do, this is 1 over 2, this is 3, so it is 3 over 2, and I can pull it out. So this becomes minus 3 over 2 integral. And now this x squared cancel one of these. So 1x here cancel 1x, and there is 1x left in the numerator. So it becomes x ln of x to power 2 dx. Oh, and please, if you see any flaws in my calculations, please let me know immediately so that I don't mess up. So apparently everything seems fine. But was this u and v that I chose successful? I would say so, yes, because my original integral is this one. I wasn't able to solve this problem yet, but I was able to reduce my problem to a new integral, which is very similar to the original one, except that instead of having exponent 3, I have exponent 2. So still this is not a trivial one, but I hope that everyone agrees that this is probably, we have a feeling that this should be simpler than the original one. So that is probably successful, I would call it. And hopefully by experience you got so far, you realize that in order to answer I have to calculate this, but because the type of this integral is very similar to the original one, it means that I need another integration by parts on this new one. So let me call this integral now j, and let us calculate j here. So if I want to calculate j, I'll have to do the same technique one more. Yes, so what does it mean? By the experience we got so far, I can write it as this and then x dx, but this time I will give the role of u to this, and I give the role of dv to this. And because this is very similar to the previous case, if you don't mind, let me do it a little bit faster. So u is ln of x squared, so if I take du becomes 2 ln of x multiplied by the derivative of ln of x, which is 1 over x, and then dx. Okay, and then if dv is equal to x dx, then it means that v is the integral of this one, which is x squared over 2. Again, this j that I want to calculate is integral of u dv. I use the formula once more, so j can be written as u times v. This time, this is my u and this is my v, so I multiply them. So it becomes 1 over 2x squared ln of x squared minus integral of the other way around, v du. So this is my v and this is my du. So let me write them down, x squared over 2 v multiplied by du, which is 2 ln of x over x and dx. Okay. Then I will continue, so this becomes 1 over 2x squared ln of x squared, and then minus this 2 and that 2 are cancelled, 1x and 1x are cancelled, so I am left with minus integral of x ln of x dx. Okay, so hopefully you are not tired of this game, because everyone probably can guess what is going to happen. Still, this integral that I get is simpler than this original integral j, because it is very comparable to this one. Instead of having 2 as exponent, now I have 1. And I hope that you agree that we can go one step forward. Yes, I hope that you are not tired, okay? So now, of course, one thing you can do, you can actually do a little bit better by doing recursion formulas. But because I'm just trying to test how this live is going, I don't want to enter very advanced techniques here, but you have to be patient a little bit, of course. So now what I will do, I will take this integral to be k, and I will do integration by parts once more, okay? So what happens here now, I would write k is equal to integral of x ln of x dx, but now for the same reason, I write it as ln x x dx. And then because this is very similar, so let me do it a little bit faster this time. So this is u and this is dv. So my du will be just dx over x, because the derivative of ln of x is 1 over x. And v is just the integral of this expression, which is x squared over 2. Okay? And now if I want to calculate my k, so my k is u times v. This is my u, this is my v, so I multiply them, so it becomes 1 over 2 x squared ln of x minus integral of v times du. Yes, so v is x squared over 2 multiplied by du. Yes, you see v du. This is the v that I plugged in, and this is my du, so it becomes dx over x. But then we are done, because this becomes 1 over 2 x squared ln of x, and then I have minus. Here I have 1 factor of 1 over 2, I pull it out, then 1x and x cancelled, I get the x dx. And finally, I am done, because this is done. It becomes 1 over 2 x squared ln of x minus, and then integral of x is x squared divided by 2. There is another factor of 1 over 2, so it becomes 1 over 4x to power 2. Yes? Okay. So I was able to find k. I have to be a little bit careful. Put it back here. Together this one and this k will give me j. And when I have my j, I take it with me and put it here. I have to remember to multiply 3/2 into everything and then combine it with the first term from the very first integration. Then finally we will be able to have our actually integral. So I don't know what is the best way to do it, because I do not have enough space and I will not remember if I want to go to the next page. Okay, so let me try to change my color to see if I can sneak around here a little bit. So here, this is k, which is this one. I put it here. Is there something I can do in my head? Yes. So this minus sign will be multiplied by k, makes this positive, and makes this negative. Okay? And then I would write it down there. So j, so let me write it here. J becomes 1 over 2 x squared ln of x squared, and then minus 1 over 2 x squared but ln of x, but minus becomes plus. This one is your j. Okay? Now I have to take this with me and plug it here in order to find I. Okay, I think I can fit it here. Sorry for the mess. So this becomes 1 over, so you see I copy and paste the first term. So it is 1 over 2x squared ln of x to power 3. And then I have to multiply the whole j by a factor of minus 3/2. So remember, I multiply minus 3/2 here, minus 3/2 here, and minus 3/2 there. So it becomes minus 3/4 x squared ln of x to power 2, and then plus 3 over 4 x squared ln of x, and finally a minus 3 over 8 x squared, then plus constant, overall constant. I hope that I haven't done something wrong. If you have detected some error, I would appreciate if you write it as a comment. Might be we can actually, you see what is happening. Let me also teach you something about these kinds of integrals. I hope that you can feel what is happening. Every time what I am doing, I am actually reducing the exponent of ln by 1. So if I go back, let us see if I can say something about this integral, but instead of having 3 there, let me have n there. Okay, so let me write it like this. So I have integral of x ln of x to power n is any natural number, and then dx. Yes, but because this I want to show the dependence of my integral to this n, instead of simply calling it I will call it I indexed n, sorry. And I will do the same thing, meaning what? So be patient a little bit. So this becomes ln of x to power n. Then I have x dx by the experience I got before. Then I give the role of dv to this guy. Then I give the role of u to this guy. Yes. And then if I want to calculate du, then it becomes n ln of x to power n minus 1, but multiplied by the derivative of ln, which is 1 over x, then multiplied by dx. And then if I ask you what v is, you know that this is just simply 1 over 2x squared. And now what I have to write is that I write in equals to, so what is happening here? This is u dv. Oh, sorry. This is u dv, so the answer is uv minus integral of v du. So uv is the product of u and v. So this becomes 1 over 2x squared ln of x to power n minus integral v du. Okay? So this is the v, so let me be patient and write it there. So this becomes 1 over 2x squared multiplied by du. So du is this whole combination. So this is, I have a factor of n, ln of x to power n minus 1, and then I have 1 over x, then I have dx. So I sub n is equal, copy and paste the first term, minus, what do I have? Here I have a factor of n and a factor of n over 2, so I can pull it out. And then what is left for me? This x to the power of 2 and this 1 over x will be simplified simply 2x, and then it becomes ln of x to power n minus 1 dx. Now, something interesting happens, yes? Can you answer this question? I want to wait a little bit for you. If I call this integral I sub n, do you have any suggestions for calling this one? Because in my previous example, I called my original integral I, then I called this one j, then I called this one k. Now, do you see any a better designation for these integrals? Let me wait for you a little bit. I named the first integral I sub n. In principle, I can call it k sub n or whatever, but is there a better name here? No answers? Yes, Jackson, you wrote Jn. No, Jn is of course not wrong, but in mathematics, this is a very general idea. If don't bring new names, if you can use the old ones. So I don't want to give up on I, because the integral that is now here is very, very similar to the integral that I called it I sub n. The only difference is that here, when I called it I sub n, the exponent was n. Here, this is exactly the same integral. The only difference is that now n is changed to n minus 1. So is there any better name that I can do this? I can call this one what? No one? Yes, very good. Very good. 21 GG. So I sub n minus 1. I would, of course, because if I ask you, for example, if I ask you what is I3, it means n is 3, then you write 3 here. If I ask you what is I4, you will have 4 here. So if you compare this integral with that integral, that's exactly identical, except that n minus 1 is substituted for n. So this is nothing except in minus 1. So what I'm saying is that the in is equal to some term minus a coefficient, but multiplied by I sub n minus 1. So I would write it here for you. So I sub n is equal to 1 over 2 x squared ln of x to power n minus n over 2 I n minus 1. Okay, so this is called a recursive relation. Okay, so it is a sequence. So I sub n defines a sequence. I couldn't find a formula directly for, I couldn't find a formula for in that connects I directly to n and x, which is the ideal scenario. But it is better than nothing. I was able to connect in to I sub n minus 1. Yes? Sometimes it is possible to solve these recursive relations and find I sub n in terms of x and n. But this is sometimes, most of the time, it is not possible. And sometimes, even if it is possible, it is extremely hard. But I would say that if I did this once, then I could use this more effectively. Yes, because what I can do, I can say that one of these integrals are very easy to calculate. Any suggestion? So you see, I have I1, I2, I3, etc. But one of these integrals is very easy to calculate. As which one is that? For example, I1 is not very hard because I1 is just this integral, yes? If you calculate that I1, then you can calculate I2. But I'm a little bit suspicious. Might be I0. I'm not sure if I0 also works or not, because I think I0 is the simplest one. But the problem is that if I have 0 here, then I have x dx, which is simply x over 2 over 2. But if I plug n equal to 0 here, because of this factor, this will vanish, and I get x squared over 2 back. So I am thinking to cheat a little bit and say that, okay, what is I0? I0 is that I replace n with 0, ln of x to power 0 is 1, and then I get x dx. So this means that this becomes integral of x dx. I have to, because when I was doing the first step, I was assuming that n is natural, but because of this n over 2 here, I think we can still do that. Let us test our chance. So this becomes x squared over 2. Okay, now look, if I want to calculate I1, I don't have to recalculate this again. I replace n with 1. Then what happens? This becomes 1 over 2 x squared ln of x to power 1 minus, because I have chosen n to be 1, this becomes 1 over 2. And then it becomes I0. Yes, because I0, I replace n with 1, so this becomes I0. But I0 is x squared over 2. So if I put x squared over 2 here and multiply it here, then I will get 1 over 2 x squared ln of x minus 1 over 4 x squared. Am I right? We can test it, by the way, because we know the solution of I1. What was the solution of I1? Let me go back here. What is I1? I1 in my notation is just this k, and I got this answer. Yes, 1 over 2 x squared ln of x minus 1 over 4 x squared. Is that the same answer I get here? One more. Yes, that's exactly this answer. So everything works fine. But now the benefit is that I don't need to do everything from scratch every time. I just replace n with 2 this time. If I replace n with 2, then it becomes 1 over 2 x squared ln of x to power 2. So don't get confused. I am replacing n with 2 everywhere. And then this becomes 2 over 2, which is just simply minus. And then it becomes I2 minus 1, which is I1, and I1 is this expression. So you see, I am calculating it recursively. Okay, and then you simplify. And then if I want to go to I3, which is my question mark, I go back here and replace every n with 3. So what happens? This becomes 1 over 2x squared ln of x to power 3. This becomes 3 over 2, but times I2. I2 is this one. So you do a simple algebra, and hopefully you can find that. So this is also a technique good to have in the back of your head, at least in your toolbox. So if you don't have any other questions, I want to end the live and thank you for joining me. Thank you very much. Bye bye. Bye bye.